Hello class, welcome to today's lesson. Our topic for today is dilution. By the end of this lesson, you should be able to 1. Define dilution. 2. Perform some simple calculations under dilution and its importance. Then the third one is a standard solution. Now, before we move on to today's lesson, don't forget to hit down the subscribe button to subscribe to my channel so that whenever I make a new video, it will send you a notification that Peter Emisa has sent a video so that you can watch. What is dilution? Now, dilution is the process of reducing the concentration of a solution by the addition of distilled water. Or you can also explain or define dilution as dilution of a solution is the addition of distilled water to decrease the solute concentration in the solution. Now, the solution we dilute is a stock solution. Now, this means before you can dilute a solution, you will need a stock solution. What is a stock solution? Now, a stock solution is a solution from which a dilute solution is prepared. Now, let me explain this. Let's take, for instance, you prepare palm nut soup in your house, or your mom prepares a palm nut soup. Now, that palm nut soup is a stock solution. Let me make a simple diagram here. So this is my palm nut soup. So this is my stock solution. Now, this is my stock solution here. Now, if I want to add water to my stock solution will now tend to be a diluted solution. So this is my stock solution. If I add the distilled water to my stock solution will now tend to be what? A diluted solution. Now, this means the stock solution's volume will increase. So this is my diluted solution. This is my stock solution. All right. Now, what will happen to a solution when it is diluted? What happens to a solution when it is diluted? So this is my stock solution. It has been diluted to this. So let me clean this stock solution and the diluted solution. Okay. So this is my solution, a stock solution. This is my diluted solution. We are saying that dilution is a process of reducing the concentration of a solution. And what is that solution? That solution is what? It's a stock solution by the addition of what? Distilled water. Now look at this and this. There's a difference in the solution. Why? There is a change in volume. Now this means when a solution is diluted, the volume will what? Will increase here. So when a solution is diluted, when a solution is diluted, one, volume increases. Second one, now this my stock solution is my palm nut soup. It's an example. This my stock solution is a palm nut soup. This my diluted solution is also my palm nut soup, because it was this stock solution from which this diluted solution was made. Because It is this stock solution. I added distilled water to this same stock solution and the volume increased to this. Now don't forget, I am assuming this stock solution as my palm nut soup. When I added distilled water to my palm nut soup, the volume increases. Now don't forget, for dilution, we are just adding water. Forget about any other things you add to the solution. Here, because I am using palm nut soup as an example, some people will say, oh, why don't I add spices and everything to the palm nut soup so that the taste will be nicer than the first one because I've added water to it. Because dilution says is addition of what? Distilled water. So our main aim here is to add water. So my palm nut soup, I added distilled water to the palm nut soup and the palm nut soup volume has increased. Now, what will also happen to the concentration? Now, the concentration of this palm nut soup or this my stock solution here is talking about, let me say, the taste of my palm nut soup. So what will happen to the taste of my palm nut soup after I have added distilled water to the what? To the solution. Don't forget, the taste will decrease. The palm nut soup taste what? Will decrease. So concentration decreases. The concentration of my stock solution will decrease. At the same time, what will happen to the amount of substance in moles? So the third one, that is amount of substance in moles. Now, my amount of substance in moles of this my palm nut soup or my stock solution here is talking about the palm nut soup itself, the stock solution itself. Now, did the palm nut soup change to a light soup? No, the palm nut soup remains palm nut soup. Even though I have added distilled water, when anyone sees the palm nut soup, the person can identify that this is indeed a palm nut soup. This means my amount of substance in moles remains the same. So my amount of substance in moles remains the same or unchanged. So if someone comes here and sees that, oh, this is a palm nut soup and I have added distilled water to the palm nut soup, the palm nut soup will still remain palm nut soup. It will not change to be a stew, or the palm nut soup will not change to be a light soup. That is my amount of substance in what? In moles. It will what? It will remain the same or unchanged. Now, let me clean this one. So, since our amount of substance in moles remains the same, we can say that moles in concentrated solution is equal to moles in diluted solution. So, our moles in concentrated solution is equal to moles in diluted solution. Diluted solution. Now, when you say concentrated solution, it means the taste of that original solution or the stock solution itself. This is the stock solution itself. It is concentrated. It means the concentration is very high, but after addition of the water, the concentration will be low. So the moles in concentrated solution is equal to moles in diluted solution because it remains the same. Our number of moles or our amount of substance, which is N, remains the same. Don't forget, we said amount of substance, it has a symbol of N and it is measured in moles. Now we can also say that at the same time, number of moles of concentrated solution is equal to number of moles of what? Diluted solution. This means number of moles of concentrated solution is equal to number of moles of diluted solution, because our amount of substance remains the same. Our amount of substance will not change. But you also know that our moles or our amount of substance N is equal to concentration times volume. So our N, amount of substance, is equal to our concentration times our what? Our volume. Are you getting it? The formula for amount of substance is N is equals to C multiplying our V. So let's take the amount of substance in the concentrated solution at the same time the amount of substance in the diluted solution, since they are the same. So amount of substance in the concentrated solution will be concentrated solution. Don't forget our N is equal to C times V. So concentrated solution will be what? C1 times V1, which is concentrated solution. So let me say N of concentrated so N of concentrated solution is equals to C1 times V1, because our N is equal to concentration times volume. So for this concentrated solution, it will be equal to C1 times V1, which is the initial amount of substance in this, which is concentration 1 times the concentration 1. Oh, sorry, times the volume 1. Because this stock solution is having a concentration which is very high and a volume which is what? Which is low. The volume here is low. Then N of diluted solution is equal to, now we have gotten a new volume here, which will be C2 times V2. Our volume increase. So our C1 of concentrated solution will be C2 of diluted solution. So you're going to get C2 times volume 2. Now this means our concentration 1 here times our volume 1 here is equal to our concentrated solution. That is our old what? Our old substance or our old solution, which is our concentrated solution or our stock solution. So this our stock solution was, which is our palm nut soup, was having a concentration and a volume. Then we diluted that what? That solution. Then we had a new concentration which decreased and a volume which increased. So we can say that C1 times V1, our new solution, C2 times V2. This is our concentrated solution, which is also known as the stock solution, and this is our diluted solution, C2 times V2. Now, since concentrated solution is equals to diluted solution, we can say that C1 V1 is equals to C2 V2. C1 V1, C2 V2. So concentrated solution is equals to diluted solution. So we can say that C1 for concentrated solution, C1 V1 is equals to C2 V2. Since concentrated solution is equal to diluted solution. And for concentrated solution, we have C1V1, and diluted solution, we also have C2V2. So mathematically, C1 times V1 is equal to what? Our C2V2, where our C1 is equal to initial concentration. Then our V1 is equal to initial volume. At the same time, our C2 will be equal to final concentration. Then V2 will also be final volume. Final volume for this whole process. Now, if C1V1 is equal to C2V2, if C1V1 is equal to C2V2. Now, don't forget, it was distilled water we added to this, then we had this. This means we can ask you to calculate for the what? The volume of water which was added to the stock solution or to the concentrated solution. We can ask you to calculate the amount of water which was added. Now, the amount of water which was added is different from the final volume of the solution. Now, look at this. At first, this was the volume, which is V1, volume 1. Now, this whole process, after we added the distilled water to the solution, this whole process became what? Volume 2, right? Now, this means this is the initial volume, this is the final volume. Now, at the same time, this volume is having concentration, which is what? C1. That is, let me say, how concentrated the solution is. It is having a very high concentration, which is the same as, let me say, the taste of our palm nut soup. So it means this will taste delicious than this. So this is the initial taste of the solution, and this is the what? The final taste of the solution. Because you have added only water to the palm nut soup, the taste what? Will decrease. So this is my C1 concentration 1. This is my concentration 2. Now look at this. This was the initial volume of the what? Of the solution. Now it has increased. Let me mark it like this. So look at this. This means this was the initial volume of the solution. But when the distilled water was added, the volume increased. Are you getting it? The volume increased. Now this means this is the amount of water which was added as vein. This is the amount of water which was added here. This is the amount of water which was added. H2O was added. Then the volume increased to this portion. Now, this does not mean it is only water which is at this place. No, the water is, even though the water is mixed, but it was because of the water that the volume increased what? To this portion. Now, look at this. If you want to find this volume, this water here, or the amount of water which was added here, we can say that our vein here is equal to my final volume, which is V2, minus my initial volume, which is V1. Now this means if I subtract the final volume from the initial volume, I am going to get this portion. I am going to get this portion. Now, someone can also use another formula to find the amount of water which was being added. You can use another formula like, now let me say this is the amount of water which was added. So let me use it as H2O. So H2O was being added. Now we are saying that C1V1 is equal to C2V2. I can also say that C1V1 is equal to my what? My C2 here. This is my C2. Multiplying my volume 2, right? But my volume 2 here will be equal to what? H2O H2O plus my H2O plus this portion. And this portion is my what? Is my volume 1. So V1. Now this means my V1 volume 1 plus my water will give me my final volume, which is here. Volume 1 here, volume 1 here, plus my H2O will give me my final volume, which is what? My V2. So H2O plus volume 1. Now let's take a question. Let's take a question. If 600 centimeters cube of 2 molar sodium hydroxide solution is diluted to 200 centimeters cube with distilled water, calculate the concentration of the diluted solution. Now, one thing you should take note that when you get the dilution question and your volume is in centimeters cube, please don't waste your time changing from centimeters cube to what? To milliliters or liters. Now, use the centimeters cube to find your answer. Don't change anything when you are performing dilution question. One thing you should take note is that you should write down the parameters given in the question so that it will seem very easy for you. If 600 centimeters cube of 2 molar sodium hydroxide, don't forget, they will give you your initial volume and your final volume. Sorry, here is 2000 centimeters cube. So let's write our parameters given in the question. Initial volume. Now, initial volume is having a symbol of what? V1, which is 600 centimeters cube. Our initial volume here is having an initial what? Concentration. Now, for concentration, you can get your value in molar. That is the molarity, which is 2 molarity or 2 molar. It's different from 2 molar mass, which is gram per mole. Now, this 2 molar here is the same as the concentration. Now, they can give your concentration in this form, or they can write it in this form, 2 mole per dm cube. So if you see this or this anywhere, they are all concentration. So my initial concentration, which is my what? C1 is equals to 2 molar. Is diluted to. We are saying that when a solution is diluted, the volume should increase. That is why here should be 2000, not 200. The volume should increase. So my final volume, which is V2, should be 2000 centimeters cube. Then we should, with distilled water, we should calculate for the concentration of the diluted solution. So that is our final concentration. Our final concentration was not given in the question, which is we don't know for our final concentration. Our final concentration is C2 here, and we don't know for C2. Now we know that our C1 V1 is equals to C2 V2. The question is we should find for C2, this one. It's either you put in the values straightforward, or you make C2 the subject, then you put in the value. So if I want to make C2 the subject, I'll have to divide by V2. So C1 V1 is equals to C2 V2. Since I want to find for my final concentration, I'll have to divide by V2 by V2 by this. So this one will get rid of this. So my C2 is equals to C1 V1 over V2. Now let me put in the values. C1 V1 is 2 molar times V1 600 cm cube over V2 2000 cm cube. Now cm cube will get rid of cm cube here. This 0 will cancel this 0, this 0 will cancel this 0. Now we are going to get 2 molar times 6 on 20, right? 2 goes here, 1, 2 goes here, 1. So 2, 10, 20. So you are going to get 6 on 10, which is the same as 0.6 mole per dm cube or molar. This is our final concentration. Now we also said when a solution is diluted, what will happen to the concentration? The concentration will decrease. This one, the concentration here is bigger than this. This means your answer is right. So your concentration here should decrease. Let's take the next example. The question says, what volume of water should be added to 200 centimeters cube of 0.5 mole per dm cube sodium hydroxide to produce 0.2 mole per dm cube solution? It says, what volume of water? This means you are calculating for the amount of water which was added to the solution, not the final volume. So write your parameters. What volume of water should be added to? So this is my initial volume. V1 as what? 200. Having initial concentration C1 as 0.5. My final concentration was given in the question as 0.2 solution, 0.2 mole per dm cube solution. Now we were not given final volume. Final volume. They were not given. V2. They were not given. The question says we should calculate for the amount of water which was added. Now I will use two procedures to find the answer. First of all, C1 V1 is equal to C2 V2. Now I have V1, C1, C2. I'll have to find my final volume. So let me find my final volume first. So C1 is 0.5 times V1, 200. It's either you put in the values or you make the other one the subject, then you put in the values. C2 is 0.2 multiplying V2. Okay, so since we want to find V2, we have to divide by 0.2. So let me write this again. 0.5 times 200 is equals to 0.2 times V2. So we divide by 0.2. We divide by 0.2. So 0.2, get rid of 0.2. Now our V2 will be equal to, now let me punch 0.5 times 200 on my phone. So 0.5 times 200, I get 100. So 100 on 0.2, then I get my final volume as 100 divided by 0.2. I get 500 centimeters cube. Now, don't forget, this 500 centimeters cube is our final volume, but not the amount of water which was added to the solution. So we now have to find our amount of water which was added to obtain this V2. So we know that our V is equals to V2 minus V1. So V is equals to, now V2 we had 500 minus our initial volume was 200 centimeters cube. So 200. Then we get our value as 300 centimeters cube for our amount of water which was what added to the solution. Now let's use a different formula to find our amount of water which was added. So let me clean this portion here. So we said our C1 multiplying our V1 is equals to what? Our V2 into bracket our H2O plus our V1. Now don't forget this V1 plus H2O is, sorry, here is C2. C2 times H2O plus V1. Now don't forget we said our V1 plus our H2O will give us our final volume, because our initial volume, we added the amount of water to the initial volume, then we had what? Our final volume, which was V2. So let's put in the values and see whether we are going to find for our H2O. So C1 here is 0.5 times our V1 here, which is 200, is equals to our C2 is what? 0.2 multiplying our amount of water added plus our initial volume, 200. 200, like this. So let's multiply 0.5 times 200, we get our 100 is equals to 0.2 multiplying H2O, we are going to get 0.2 H2O. It's the same as you saying 0.2 times X, we are going to get 0.2 X plus 0.2 multiplying 200, we are going to get 40, right? 0.2 times 200 is 40. So let's group like 10. So this 40 will move to the equal to sign to be negative. So 100 minus our 40 is equals to 0.2 H2O. 100 minus 40, we're going to get 60 is equals to 0.2 H2O. Now we want to find our amount of water which was added, so we have to divide by what? 0.2. So So 60 is equal to 0.2 H2O. We divide by 0.2, we divide by 0.2. So our amount of water added is equal to 60 over 0.2, where we are going to get our amount of water which was added as 300 centimeters cube. Now, if you use this formula, C1 V1 is equal to C2 into bracket H2O plus V1, you are going to find for the amount of water which was added straightforward without you using your V is equals to V2 minus V1. Now, this means for V is equals to V2 minus V1, you are going to what? Find your final volume. Then you subtract your what? Initial volume from your final volume. Then you get your what? Amount of water, which was what? Added to the solution. Now, I will give you an exercise, then you submit for me. Now, let's move on to importance and applications of what? Dilution. Let's say the first importance. So, first, dilution is applied in medicine to reduce the concentration of what? Microscopic organisms or cells in a sample. That's the first one. Then two is dilution is used to prepare medicines of accurate concentration. So if you want to prepare medicines of accurate concentrations, then you have to what? Use you apply dilution factor. Now next one is it is used in preparation of what? Food, example beverages, so drinks. Then in our homes, this our antiseptics, disinfectant and some detergent are also diluted before they can be used, right? Yeah, you know them. Then it is also used in the acidic content determination in the soil. Let's move to what is a standard solution? Now, a standard solution is a solution which contains known amount of solute in a given volume of a solution. That is a standard solution. Or a standard solution is a solution whose exact concentration is known. Now, this means if you are asked to calculate or find or perform an experiment on a standard solution, you have to know the exact concentration of that solution. Now, how to prepare a standard solution? So we have steps you should take when you want to prepare a standard solution. Now, don't forget your apparatus. One, we have stirring rod, we have wash bottle, beaker, volumetric flask, spatula, funnel, and a balance, or you can say a weighing balance. So before a standard solution can be prepared, the following must be known. One, you have to know the molecular formula of the compound. So let's take for instance, if you want to prepare sodium hydroxide. Sodium hydroxide, so standard solution. So let's take for instance sodium hydroxide. If you want to prepare sodium hydroxide, you have to know the molecular formula of sodium hydroxide. So you say sodium hydroxide. Sodium is what? Na. Hydroxide is what? OH. Sodium is having a charge of plus, hydroxide is minus. We do our cross, we get our NaOH. So this is our what? Our molecular formula for the compound. At the same time, the molar mass of the compound, you have to know the molar mass of that compound you want to prepare. So let's take for instance, sodium is what? Having an relative atomic number Na is 23, oxygen is what? 16, hydrogen is equals to 1. So this is what we are talking about. Then you use this to calculate for your what? For your molar mass. So molar mass of NaOH. Then you calculate it as sodium multiplying oxygen plus hydrogen. To put in the values 23 plus 16 plus 1. Then you get your what? 40 grams per mole as your what? Molar mass. Then the concentration of the solution required. So the concentration, you have to know the concentration. It means we will give you the concentration. So concentration, you can get it as 0.2 molar, which is the same as 0.2 mole per dm cube. Please, 0.2 molar or 0.2 mole per dm cube is an example. This does not mean any compound will be given the concentration as 0.2 molar or 0.2 mole per dm cube. Next one is our volume. Now, the volume can be in centimeters cube or dm cube or in milliliters. So we will give you the volume of the solution, then you use it. Okay, so our first question under standard solution. Okay, so first question: prepare 1000 centimeters cube into bracket 1 dm cube of 0.5 molar sugar solution. Okay, so let me write the question. So we have to prepare 1000 centimeters cube into bracket 1 dm cube of 0.5 molar sugar solution. Let me give you the values. C is equals to 12, hydrogen is equals to 1, oxygen is equals to 16. So we have to prepare 1000 cm cube of sugar solution. And the sugar solution here, we will need a sample of which we are going to use. And this is the granulated sugar. We are going to use the granulated sugar, also known as the sucrose. And the formula for sucrose is C12H22O11. So this is what we are going to use to prepare the sugar solution. So this is their masses. So what is the first step? We said now you have to know the molecular formula of the compound. And the molecular formula of the compound is C12H22O11. Then next one is we have to calculate the molar mass. Now you can get a question where they will ask you to prepare a solution. This means you are going to list all the apparatus and you are going to use all the formulas, the procedures. So your aim, what is the aim of the experiment? So the aim of the experiment is to prepare a sugar solution. Your aim, you are to prepare a sugar solution. So aim to prepare a sugar solution. Then you list your apparatus. The apparatus you are going to use. So apparatus, we have stirring rod, balance, wash bottle, volumetric flask, beaker, spatula. So these are my apparatus. Don't forget your funnel. Your funnel, because you are going to use to transfer the solution. So let me add the funnel. Okay. Then we calculate for our molar mass. So molar mass of our sucrose, molar mass of C12H22O11, which is carbon multiplying 12 plus hydrogen multiplying 22 plus our oxygen multiplying 11. Our oxygen is multiplying 11. So let's put in the values. So carbon is 12, times 12 plus hydrogen 1 times 22. So hydrogen is 1 here, plus oxygen here, 16 multiplying 11. 16 multiplying 11. So 12 times 12, I'm going to get 144, plus 1 times 22 is 22, plus 16 times 11 is what? 176. So 16 times 11 is 176. So I add all this. I'm going to get 342 grams per mole. 342 grams per mole. So this is the what? This is the molar mass of the sucrose. Now, don't also forget your mass. You have to use the mass because it is the mass we are going to weigh. So we will weigh the amount. Don't forget we have to prepare 0.5 molar sugar solution. This means your sucrose, you have to weigh that your what? Your mass. And how are you going to weigh your mass? You use the molar mass of the sucrose to what? To the molar mass, your volume, and your concentration. Now you use this to find your mass. Then you can now say that, oh, when I calculated for my mass, I had 20 grams or 30 grams of the sucrose. This means I'm going to weigh 20 grams of my sucrose. Then I what? I will use in the preparation. So now, don't forget our M is equals to concentration times molar mass times our volume. I'm sure you remember this formula. Now, this formula, we derive this formula from C is equals to N over V. At the same time, N is equals to small m over big M. Do you remember this? So, C is equals to N over V. N is equals to small m over big M. Now, if N is equal to small m over big M, now I can use this to find my mass. Right? This means I have my concentration here, I have my volume here, 1 dm cubed. So I can use this formula to find my amount of substance. So if I find my amount of substance, I can now put my amount of substance in this formula here. I have my molar mass here, molar mass, then I use it to find my mass. If I don't want to use this long process, then I can just use this formula as my mass is equals to concentration times molar mass times volume. Now let me put in the formula. I'm going to get the answer straightforward. Same here. You apply these two formulas, you are going to still get the same answer as mine. So let me use my concentration here. Concentration is 0.5 times my molar mass is what? 342 times my volume. Now 1000 centimeters cube is the same as 1 dm cube. Don't forget you have to change 1000 centimeters. You are going to get 1 dm cube, so which has been already written in the question. So my volume here is 1. We are going to use the 1. Please, apart from dilution, standard solution, we have to change the volume. It is only dilution we don't convert from centimeters cube to what? dm cube. Now 0.5 times 342 times 1. Let me punch my calculator. I'm going to get my mass as 171 grams. I'm going to get my mass as 171 grams. So how is the steps going to be? How am I going to write my steps? So first one, I will say that's the first step. So now this means I'm down calculating for my mass, my molar mass. I have my parameters here. So I will now have to write the procedure, how I am going to what? Prepare the solution. So first step, using a weighing scale, weigh out 171 grams of granulated sugar into a beaker containing some amount of what? Distilled water. So I will now weigh 171 grams of my granulated sugar. Then I will put my granulated sugar of the one I weighed. I'll put it in a beaker containing distilled water. Now 2, I will dissolve the sugar in the beaker by stirring for a while using what? A stirring rod. So I will, since my granulated sugar is in the beaker, I will now stir it. I will stir it using my what? Stirring rod. I will stir them. Then what will happen? So I now add the sugar to a volumetric flask. So I will add the sugar solution, the one I stirred. I will add it to a volumetric flask or beaker. Gradually, I will add the distilled water while stirring until the total volume reaches what? 1000 centimeters cube. So let's say if this is my volumetric flask, so this is the one I'm going to what? I'm going to put my solution in. Now, they all have, because it is granulated, it means they have indications. So this is, let me say, here is thousand centimeters cube. Here is, let me say, 500. Can say here is, let me say, 250 cm cube. So I will have to what? Put the solution in this so that the whole solution gets to the mark of what? 1000 centimeters cube, because the question says you should prepare 1000 cm cube. So the solution should get to what? 1000 centimeters cube. Now, if you prepare the solution and it's not up to 1000 centimeters cube, you have to what? Add distilled water to it so that it reaches the mark of what? 1000 centimeters cube. Let's continue. So after you label the container with what? Concentration. So you label the container. This one, you label it. So this is 1000 cm cube what? C12 H22O11. So this is sugar solution. 1000 cm cube C12 H22O11 0.5 molar solution. So you label the what? Concentration. You add the date to it. So you add the date as 29/0 days 2026 or any date. The date you use to prepare the what? The solution. Then you are done. So I will leave an exercise, then we'll continue with our lesson next week. Don't forget to subscribe to my channel. I'll be looking at it.